This video is about polar function graphs. This is AP Precalculus, topic 3.14. If you appreciate the content, please give it a like. Number 1. The figure shows the graph of the polar function r equals f of theta on the interval from 0 to 2 pi in the polar coordinate system. Which of the following could be an expression for f of theta? We can often eliminate two options by letting theta equal 0. At 0 radians on the unit circle, we have the point 1, 0. We know that sine is the y value and cosine is the x value, so the sine of 0 is 0 and the cosine of 0 is 1. Substituting 0 for sine theta and 1 for cosine theta, these are the values of the four options when theta is equal to 0. When theta is equal to 0 radians, we do see points at an r value of 2 and -2, which would be in the opposite direction. So A, B, and C are still possible. We do not see a value at r equals 6. So C is definitely not the answer. Next, let's let theta equal pi over 2 and see if we can eliminate more options. At pi over 2 on the unit circle, we have the point 0, 1. Again, sine is the y value and cosine is the x value, so the sine of pi over 2 is equal to 1 and the cosine of pi over 2 is equal to 0. Making these substitutions, we find that these are the values of the three remaining options. At pi over 2 on the graph of f of theta, we see r values of 6 and 2, but not -2, so that means option B is out. Let's see if we can narrow it down to the final answer by letting theta equal 3 pi over 2. At 3 pi over 2 on the unit circle, we have the point 0, -1. Sine is the y value, and cosine is the x value. At 3 pi over 2, the value of option A is -2, and the value of option D is +2. At 3 pi over 2 on the polar grid, an r value of 2 would be right here on this blue line. But this point is not a point on the graph, so the answer is not D. On the other hand, an r value of -2 would be in the opposite direction from this blue line. It would be right here, which is on the graph. That's why the answer is A. In retrospect, letting theta equal 3 pi over 2 would have eliminated all of the incorrect answers in the first try. Number 2. The figure shows the graph of the polar function r equals f of theta on the interval from 0 to 2 pi in the polar coordinate system. Which of the following could be an expression for f of theta? Let's see how many options we can eliminate by letting theta equals 0. The sine of 0 is 0 and the cosine of 0 is 1. These are the values of the four options when theta is equal to 0. At 0 radians on the polar graph, an r value of 3 would be right here. This is not a point on the graph of f of theta, so options A and B are out. An r value of 6 would be right here. This is not a point on the graph of f of theta either, so C is out. D is the answer, because an r value of 0 would be right here, which is a point on the graph of f of theta. I'm not going to read the problem to you again. It is the same thing, my friend. You can do a lot of this in your head, guys. At a glance, I can tell that none of these options will be eliminated if we let theta equal 0. At theta equals 0, the four options have a value of 6 or 0. On the polar graph, at 0 radians, 6 is an r value, and 0 is also an r value. Nothing is eliminated. It would be a similar story at pi over 2, pi, or 3 pi over 2. Let's see what happens when we let theta equal pi over 4. The cosine of 2 theta becomes the cosine of 2 times pi over 4. This reduces to the cosine of pi over 2, and we know that the cosine, the x value at pi over 2, is equal to 0. 6 times 0 is 0. On the polar graph at pi over 4 radians, we do see an r value of 0. So a is still in. On the other hand, the cosine of 4 theta becomes the cosine of 4 times pi over 4. This simplifies to the cosine of pi, which is equal to -1. At pi, we are 1 unit to the left on the unit circle. So -1. So that gives us 6 times -1, which is -6. At pi over 4 on the polar graph, +6, an r value of +6 would be right here. An r value of -6 would be in the opposite direction, which would be right here. This is not a point on the graph of f of theta, so option B is eliminated. What about option C? 6 times the sine of 2 theta becomes 6 times the sine of 2 times pi over 4. This simplifies to 6 sine pi over 2. The sine of pi over 2 is 1. That's the y value. So this is 6 times 1, which is 6. At pi over 4 radians on the polar graph, an r value of 6 would be right here. This is not a point on the graph of f of theta, so option C has been eliminated. Option D becomes 6 times the sine of 4 times pi over 4, which simplifies to 6 sine pi. The sine of pi is 0, so this will be 6 times 0, which is 0. This cannot be eliminated because at pi over 4 radians, we do have an r value of 0. Let's see if we can narrow it down to the final answer by letting theta equal pi over 6. Option A becomes 6 cosine 2 times pi over 6, which simplifies to 6 cosine pi over 3. Option D becomes 6 sine 4 times pi over 6, which simplifies to 6 sine 2 pi over 3. If you have not yet memorized the 9 trig values on this chart, I don't know what you're waiting for. Pause the video and get it done right now. We have memorized that the cosine of pi over 3 is 1/2. So option A becomes 6 times 1/2, which is 3. On the polar grid at pi over 6 radians, an r value of 3 would be right here. And there is a value of f of theta at this point. So A is still an option. The sine of 2 pi over 3 will be the same as the sine of pi over 3, which is radical 3 over 2, except it might be negative depending on the quadrant. 2 pi over 3 is in the second quadrant, and y values, and thus the sine function, are positive in the second quadrant. So the sine of 2 pi over 3 is positive radical 3 over 2. This simplifies to 3 radical 3. This value is definitely bigger than 3. And on the polar grid at pi over 6 radians, we see that an r value of 3 is right here, and there are no r values bigger than 3 that are on the graph of f of theta. So option D has been eliminated, leaving option A as the answer. Number 4. A portion of the polar function r equals f of theta, where f of theta is equal to 3 sine 2 theta, is shown in the polar coordinate system on the interval from a to b. If a is less than b, and a and b are both between 0 and 2 pi, which of the following could be values for a and b? For problems like this, I like to sketch a rectangular graph of the function. We know that the b value of 2 is going to change the period from the normal 2 pi. The period of a sine or cosine function is given by 2 pi divided by the b value, So in this case, that's 2 pi divided by 2. So the period of f of theta will be pi. If I count out 4 marks, 1, 2, 3, 4, I'm going to call that pi. Then halfway is going to be pi over 2. And half of that will be pi over 4. I can use this pi over 4, the quarter period, to identify the value of any of the missing values that I want. I can basically count by pi over 4. This is 1 pi over 4, this is 2 pi over 4, this would be 3 pi over 4. Then I have 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, and 8 pi over 4, which reduces to 2 pi. The 3 in the front tells us that the amplitude is going to be 3. So we will have a high of 3 and a low of negative 3. We have memorized that one period of the sine function looks like this. I'm going to sketch another period because I want to go all the way from 0 to 2 pi. Option A represents the interval from pi over 4 to pi over 2. On the rectangular graph, that's going to be from here to here. Notice that on the interval from pi over 4 to pi over 2, the r values are all positive, so we don't have to worry about moving in the opposite direction and ending up in the opposite quadrant. Therefore, on the interval from pi over 2 to pi over 4 on the polar graph, we should see a portion of f of theta, and we don't. So that means option A is not the answer. Option B represents the interval from pi over 2 to pi. That's from here to here on the polar grid. However, notice that on the interval from pi over 2 to pi on the rectangular grid, we can see that the values of r are negative. We are below 0. Therefore, we do need to worry about moving in the opposite direction. So as the value of theta moves through the second quadrant from pi over 2 to pi, the r values will be graphed in the fourth quadrant between 3 pi over 2 and 2 pi. So far, option B is looking like a very possible answer. I want to make one more connection with you. On the rectangular graph, the midline of 0 represents the pole. Notice how on the interval from pi over 2 to pi, the function starts at the pole, moves away from the pole, and then back to the pole. That is exactly what we see on the polar graph, which begins at 0, moves away from the pole, and then goes back to the pole. So I'm betting B is the answer. Let's see if we can quickly eliminate options C and D. Option C represents the interval from 3 pi over 4 to pi. On the polar graph, that's going to be from here to here. However, on the rectangular graph, we notice that the r values are all negative. So the r values will be on the opposite quadrant between here and here. So if C was the correct answer, we would only see this portion of the graph that goes like this. It would leave out the other portion of the graph. So C is not the answer. Option D represents the interval from 3 pi over 2 to 2 pi. On the polar graph, that would be from here to here. At first glance, that looks pretty good because we see a portion of the graph in this quadrant. However, a glance at the rectangular graph tells us that the r values are negative between 3 pi over 2 and 2 pi. So the actual graph would appear in the opposite quadrant, and we see nothing, so D is not the answer. So this confirms that the answer is B. Number 5. A portion of the graph of the polar function r equals f of theta where f of theta is equal to 3 times the cosine of 3 theta, is shown in the polar coordinate system on the interval from a to b. If a is less than b, and a and b are both between 0 and 2 pi, which of the following could be the values for a and b? As before, let's draw a rectangular graph for f of theta. We see a b value of 3, and the period of a cosine function is given by 2 pi divided by the b value, so 2 pi over 3. Counting out 1, 2, 3, 4 marks, this will be the end of the period. This will be 2 pi over 3. Half of 2 pi over 3 is 1 pi over 3. And half of pi over 3 is pi over 6. This is the quarter period, and I can use that to find the value of any missing input values. I can count by pi over 6. This is 1 pi over 6, 2 pi over 6. 3 pi over 6 is the same as pi over 2. 4 pi over 6. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. Then we have 11 pi over 6. And of course, 12 pi over 6 is 2 pi. We have memorized that one period of a cosine function looks like this. The midline is 0. The 3 in the front tells us that we will have a high of 3 and a low of negative 3. Here's a second period, and here's a third period. I like to keep going until I get to 2 pi. Option A represents the interval from 0 to pi over 6. On the polar graph, that would be from here to here. On the rectangular graph, the interval from 0 to pi over 6 goes from here to here. Notice that the r values are positive on this interval, so we don't have to worry about moving in the opposite direction and ending up in a different quadrant. If option A was the answer, we would expect to see a portion of the graph right here in the first quadrant. We don't, so the answer is not A. Option B represents the interval from pi over 6 to pi over 3. That's from here to here on the polar graph. From pi over 6 to pi over 3 is from here to here on the rectangular graph. Notice that the r values are negative, so the actual graph would be in the opposite quadrant. If option B was the answer, we would see a portion of the graph right here. We don't, so option B is not the answer. Option C represents the interval from pi over 3 to pi over 2. That's from here to here on the polar graph. Or on the rectangular graph, that would be from here to here. Notice that the r values are negative, so we would expect to see a portion of the graph in the opposite direction between here and here. We do. So far, so good. Also, remember that the midline of 0 on the rectangular graph represents the pole. Notice that on the interval from pi over 3 to pi over 2, we are starting at a distance of 3 away from the pole, and we are ending up at a distance of 0. As theta goes from pi over 3 to pi over 2, because of the negative r values, the graph of f of theta will go from here to here. Notice that just like on the rectangular graph, the r values start at a distance of 3 away from the pole and end up at a distance of 0. So I'm pretty sure that C is the answer. Let's follow through and show why option D is not the answer. Option D represents the interval from 5 pi over 4 to 3 pi over 2. That's going to be from here to here on the polar graph. 5 pi over 4 is a little bit bigger than 7 pi over 6. So 5 pi over 4 to 3 pi over 2 would be from here to here on the rectangular graph. The positive r values tell us that we don't have to worry about moving in the opposite direction, so we would expect to see a portion of the graph on this interval. However, I'm going to erase the blue line so you can see that this is close, but not quite. Can you see how the graph stops right here? We're getting a portion of the graph only from here to here. The graph would keep going if option D were the answer. We would see more of the graph. It wouldn't stop right here the way it does. So option D is not the answer. The answer is in fact C. Number 6. A portion of the graph of the polar function r equals f of theta, where f of theta equals 2 plus 4 cosine theta, is shown in the polar coordinate system on the interval from a to b. If a is less than b, and a and b are both between negative 2 pi and positive 2 pi, which of the following could be the values for a and b? As before, I'd like to sketch a rectangular graph of f of theta. The b value is 1, so the period will be the familiar 2 pi. However, the plus 2 in the front would be the same as adding plus 2 on the end. This is a new midline instead of the x-axis. So the midline is going to be 2. The 4 right here, the a value, tells us the amplitude is 4. So the maximum value will be 4 above 2, which is 6, and the minimum value will be 4 below 2, which is negative 2. We have memorized that one period of a cosine function looks like this. Since we need to go from negative 2 pi to 2 pi, here's another period. Option A represents the interval from negative 2 pi over 3 to positive 2 pi over 3. That's from here to here on the polar grid. Correction, that was a mistake. This is the interval from negative pi over 3 to pi over 3. The interval from negative 2 pi over 3 to positive 2 pi over 3 actually goes from here to here. Please ignore this mistake. It does not change the answer. Negative 2 pi over 3 and positive 2 pi over 3 are not showing up among my quarter period marks. I'm thinking they might be x-intercepts. So let's find the x-intercepts of this graph by setting f of theta equal to 0. We begin to solve by subtracting 2 from both sides, giving us 4 cosine theta is equal to negative 2. Next, we divide both sides by 4. Negative 2 over 4 simplifies to negative 1/2. So we have cosine theta is equal to negative 1/2. We can identify the reference angle by ignoring the negative sign and asking ourselves the cosine of what angle is 1/2. We have memorized that the cosine of pi over 3 is 1/2. So pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are all the angles with a reference angle of pi over 3. Because we want the cosine to be negative 1/2, we need to stick to quadrants 2 and 3, where the x values, and thus the cosine, will be negative. We can think of pi as 3 pi over 3, so this angle in the second quadrant is 2 pi over 3, and this angle in the third quadrant is 4 pi over 3. These are two solutions, but they are not the only solutions. The period of cosine is 2 pi, so you will get another solution every time you add or subtract 2 pi. I am subtracting because I'm trying to get the x-intercepts over here on the left side. Subtracting 2 pi is the same as subtracting 6 pi over 3. 2 pi over 3 minus 6 pi over 3 is negative 4 pi over 3. And 4 pi over 3 minus 6 pi over 3 is negative 2 pi over 3. So here are 4 x-intercepts. And here are those 4 x-intercepts on the rectangular graph. On the rectangular graph, negative 2 pi over 3 to positive 2 pi over 3 goes from here to here. Notice that on this interval, the r values are all positive, so we don't have to worry about reflecting into the opposite side of the graph. So we would expect to see a portion of the graph on this interval, and we do see that. So A is a possible answer. But wait, not so fast. On the interval from negative 2 pi over 3 to positive 2 pi over 3, the value of f of theta starts at 0 and then increases to a maximum value of 6 and then goes back to 0. By contrast, on the polar graph, the distance from 0 starts at 0 and increases to a maximum value of 2 and then decreases back to 0. So we are not getting to this maximum value of 6, so option A is actually not the answer. The interval from negative pi over 3 to positive pi over 3 goes from here to here on the polar graph. On the rectangular graph, it's going to be somewhere in here. I don't know exactly where it begins and ends, and I don't need to. I can see that the r values should be reaching a maximum value of 6 on this interval. But looking at the polar graph, again, the r values reach a maximum value of 2. So B cannot be the answer. Option C represents the interval from pi over 2 to 3 pi over 2. On the polar graph, that's from here all the way around to here. On the rectangular graph, from pi over 2 to 3 pi over 2 is from here to here. Notice that at pi over 2, we begin with an r value of 2. So here at pi over 2, I would expect to see a point right here, and we do not. So right there, I know that option C is not the answer. We already know this is not the answer, but let me say a little bit more. We are starting with an r value of 2, and for a little while, between pi over 2 and 2 pi over 3, the r values are positive. So we're not talking about any reflections into the opposite quadrant. So on this first little interval from pi over 2 to 2 pi over 3, we would expect to see a portion of the graph that is in this quadrant. And then we go negative, so we would expect to see something reflected into the opposite quadrant, which is probably where something like this would come from. And then between 4 pi over 3 and 3 pi over 2, we're back into the positive zone again, which is where we would expect to see a portion of the graph right here in the appropriate quadrant. So again, the absence of these two positive r-value portions of the graph on the interval between pi over 2 and 3 pi over 2 means that option C cannot be the answer. By the process of elimination, we know that D must be the answer, but let's follow through and see why it makes sense. Option D represents the interval from 2 pi over 3 to 4 pi over 3. On the polar graph, that's going to be from here to here. On the rectangular graph, 2 pi over 3 to 4 pi over 3 goes from here to here. Because of these negative r values, the graph will be in the opposite direction from where theta is. So as theta goes from 2 pi over 3 to 4 pi over 3, the graph will actually appear in this area, drawn from here to here. And we do see this portion of the graph in this interval. Now, what about the r values? At 2 pi over 3, the r values should start at 0, and then the distance from the pole should increase to a maximum distance of 2, and then return to the pole. And that's exactly what we see. As we rotate from here to here, the r value starts at 0, and the distance from the pole goes to a maximum of 2 before returning back to 0. This is confirmation that D is the answer. Number 7. The figure shows the graph of the polar function r equals f of theta, where f of theta equals 6 times the cosine of 2 theta, in the polar coordinate system on the interval from 0 to 2 pi. Here it says there are 4 points labeled, but there are actually 5, A, B, C, D, and E. If the domain of f is restricted to the interval from pi over 2 to pi, the portion of the given graph that remains consists of 2 pieces. One of those pieces is the portion of the graph in quadrant 4 from D to E. Which of the following describes the other remaining piece? As before, let's make a rectangular graph. Because of the b value of 2, we know that the period will be 2 pi divided by the b value of 2. So the period is going to be pi. That's why I'm going to count out 4 quarter periods, 1, 2, 3, 4, and I'm going to call it pi. Half of that will be pi over 2. Half of that will be pi over 4. Now I can count by pi over 4. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, and 8 pi over 4 is 2 pi. The 6 in the front tells us that the amplitude will be 6, so we will have a maximum value of 6 and a minimum of negative 6. We have memorized that one period of cosine looks like this. Here's a second period taking us to 2 pi. If the domain of f is restricted to the interval from pi over 2 to pi, on the polar graph we are talking about the interval from here to here. On the rectangular graph we are talking about the interval from here to here. Let's trace this portion of the polar graph in purple. We are starting at pi over 2, but notice that at pi over 2 the r value is negative 6. So here we are at pi over 2, but a negative 6 will be in the opposite direction. It'll be right here. So this is the starting point. Let's talk about the portion of the graph that goes from pi over 2 to 3 pi over 4. Pi over 2 to 3 pi over 4 on the polar graph is from here to here. However, because these r values are negative, the graph will appear in the opposite portion of the graph between here and here. And again, notice that we are beginning with an r value of negative 6. That's 6 away from the pole. As we move from pi over 2 to 3 pi over 4, which will be from here to here because of the negative r values, the distance from the pole will go from 6 to 0. So we are talking about the portion of the graph that goes from here to here. In the setup, we were told that on this interval, one piece of the graph is in quadrant 4 from D to E. That's the portion of the graph that we just identified. Here we are in quadrant 4 from D to E. Now we need to identify the other portion of the graph included by this interval. So it's going to come from the portion of the graph between 3 pi over 4 and pi. On the polar graph, 3 pi over 4 to pi is from here to here. On the rectangular graph, we notice that the r values from 3 pi over 4 to pi are positive, so there will be no reflection into the opposite quadrant. The graph should appear between 3 pi over 4 and pi, right here in the second quadrant. Notice that from 3 pi over 4 to pi, the r values go from 0 to 6. So we begin at the pole, and then we go to a maximum value of 6. So at 3 pi over 4, we begin at the pole, and then we go to a maximum value of 6. That's from E to A. So the answer is B. The remaining piece is the portion of the graph in quadrant 2 from E to A. Number 8. The figure shows the graph of the polar function r equals f of theta, where f of theta is equal to 6 sine 2 theta in the polar coordinate system on the interval from 0 to 2 pi. There are 5 points labeled A, B, C, D, and E. If the domain of f is restricted to the interval from pi over 2 to 3 pi over 4, which of the following describes the portion of the given graph? As usual, let's make a rectangular graph. Because of this b value of 2, we know the period will be given by 2 pi divided by that b value, 2 pi over 2. So the period will be pi. That's why I'm going to count out 4 quarter periods, 1, 2, 3, 4, and I'm going to drop a pi. Half of pi is pi over 2, half of that is pi over 4, and then I begin to count by pi over 4. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, and 8 pi over 4 is 2 pi. There is no vertical shift, so the midline is 0. The a value of 6 tells us that the amplitude is 6, so 6 above 0 is a maximum of 6, and 6 below 0 is a minimum value of -6. If the domain of f is restricted to the interval from pi over 2 to 3 pi over 4, on the polar graph, we are talking about the interval that goes from here to here. We have memorized that one period of the sine function looks like this. We can draw more if we need to, but this may be enough. If the domain is restricted to the interval from pi over 2 to 3 pi over 4, on the polar graph, we are talking about the interval from here to here. On the rectangular graph, we are talking about the interval that goes from here to here. Because of the negative r values, as theta moves from pi over 2 to 3 pi over 4, the graph will appear in the opposite quadrant, and it will be drawn specifically from here to here. As we trace this portion of the graph in green, notice that the distance from the pole, represented by the midline, starts at 0 and then increases to a maximum value of 6. So again, I'm tracing in this direction, and I'm starting at a distance from the pole of 0, and then I am increasing to a maximum distance from the pole of 6. So that is from E to C. So the answer is D, because it describes the bottom portion of the graph in quadrant 4 from E to C. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.